Today we see sound chapter. In this chapter we study about how to study a sound is produced and why are some sounds louder than others, what is music, how does sound travel from one place to another, and what is noise pollution and how it is caused, how is music different from noise. We shall discuss all such questions in this chapter. Do you know and do you hear sounds from various sources like moving vehicles, television, music system, machines, musical instruments, and so on? You already know sound is a form of energy like heat and light, and also electrical energy, mechanical energy. Okay, sound is also a form of energy. Sound is a form of energy that produces a sensation of hearing in our ears. We talk and communicate with others by producing sound. That is, bird sound, insect sounds, and animal sounds are also capable of producing sound. So, when we talk about sound, so many questions arrival to our mind. That is, already I told you how to we hear sound, how is sound produced, and etc. Now we see the vibrations. What is meant by vibrations? Do you know vibration? That is, vibration is rapid back and forth movement of an object about its mean positions, or vibration is a rapid to or to and fro movement of an object about its mean position. So this why we study these vibrations, because when you pluck the strings of a guitar, you notice that the string start moving back and forth rapidly, making a sound. So these vibrations produced sound. Okay, when you place your palm on the speaker of a music system playing loud music, you feel some back and forth movements. Do you feel this one? Back and forth movements because of these vibrations. Okay, this is called the vibrations. Already told, that is a vibration is a to and fro or back and forth movement of an object about its mean position. So the sound is produced because of vibrations. So, do you understand these vibrations? The sound produced because of vibrations. Next, sound is produced by a vibrating object. Every source of sound is a vibrating object. In other words, every vibrating object produces sound, because when vibrations are stopped, the sound also stops. Thus we can say that sound is produced by vibrations made by vibrating object. Let us perform the following activities to show how sound is produced by a vibrating object. So we do in your home, You take a wooden board or a cardboard and take a 2 iron nails, a rubber band and a hammer. Take a 2 iron nails, fix on the wooden board or cardboard with the help of a hammer. Tie a rubber board between the 2 ends of the iron nails. So stretch the rubber band and then leave it. Cardboard or wooden board, you fix the 2 iron nails. The rubber band is tie 2 nails and you stretch the one of the rubber bands are stretched. And released. What happened? This rubber bands are vibrating back and forth motion. Its mean position. This is a mean positions. So it will vibrate back and forth motions. So at the time the rubber band vibrate, some sounds are produced. So sound is produced by a vibrating object. We prove that this experiment. Next one is tuning fork. A tuning fork is a U-shaped single steel piece with a handle. This one is a tuning fork. In your home, in kitchen, we saw the fork. In hotel also we saw the fork. That type of fork is called tuning fork. It have two arms of tuning fork called prongs and the stem. This stem is called this handle is called stem, and two arms of tuning fork called prongs. It is a convenient source of producing sound in laboratory. Now we do the activity to show that a vibrating tuning fork produces sound. Make two small holes in a table tennis ball or less weight ball. You take a two table tennis ball or less weight ball, make a hole on it and pass a thread through it. Suspend the table tennis ball or a less weight ball with the thread tied to the stand. This stand is made up of iron. Strike a tuning fork against a rubber pad. This one is a rubber pad. So strike out this tuning fork against this rubber pad. So this tuning fork vibrates. The prongs are vibrates. Bring one of the prongs of the vibrating tuning fork kept near this ball, and touching the prong of the tuning fork, the ball starts vibrating to and fro motions. This shows that tuning fork is vibrating, that makes the ball vibrate. Thus, we can see that sound is produced by a vibrating tuning fork. Next, how sound travels. We have learned that sound is produced by the vibration of an object. The vibrating object produces sound in the form of energy. This energy transfers to the air molecules close to it. These air molecules also start vibrating back and forth with the same frequency. These vibrating air molecules pass on their vibrations to the next air molecules. This process goes on and ultimately all the air molecules around the sound producing object start vibrating back and forth. When the vibrating air molecules fall on the air drum, we feel these vibrations as sound. So we need the sound need a medium to travel. In vacuum, sound does not travel because vacuum have no air particles. So it will not take the vibrations. So sound needs a medium to travel. It does not travel in a vacuum. Next, sound needs a medium to travel. The substance or matter through which sound is transmitted is called a medium. So, matter through which sound is transmitted is called medium. Not only sound but also light. And light travel in vacuum, but also it will travel in medium. The medium can be solid, liquid or gas. Any type of medium it will travel. When your school bell rings, the bell vibrates and produces sound. The sound travels through air and finally reaches our ears, that means the listeners. So, sound moves through a medium from its source to the listener. So, sound moves through a medium from its source to the listener. Let us perform the following activities to know how sound travels in a medium. To show that sound can travel through solids. So the apparatus requires that activities are an alarm clock and a wooden table. So you close the doors and windows of your room so as to cut the outside noise. Place an alarm clock at one end of the wooden table and stand at the other end of the table. Try to hear the ticking sound of the alarm clocks. Now, second, you place your ear on the table. Here is your ear on the table and listen. What you observe? You observe that the ticking of the alarm clock sounds louder when heard through the wood. So in this case, we stand at the other end of the table. You hear the ticking sound of the alarm clock. It is very slow. It is, but in the case of your ear on the table, the sounds of the alarm clock is louder. So we prove that sound travels faster through a solid medium than a gaseous medium. Sound travels through solids and also sound travels faster through a solid medium than a gaseous medium. Next we see the activity 4 to show that sound can travel through liquids. Things needed a squeaky toy, It means a toy that produces sound on pressing. A plastic bag, a thread, a bucket, and some water. Take a squeaky toy and put inside a plastic bag. Tie the mouth of the bag with a thread. Fill a bucket with water and place the plastic bag containing squeaky toy in the water. Now squeeze the toy. What happened? Some sounds are here. Now put your ear just above the water level in the bucket and squeeze the toy again. You hear a low sound. When you put your ear just touching the water level in the bucket, you hear a louder sound. Then we can conclude that sound travels through liquids. Sound travels faster through a liquid medium than gaseous medium. From this activities 3 and 4, it is clear that sound travels through solids, liquids and gases. Now let us perform an activity to show that sound cannot travel in vacuum. Next activity is to show that sound requires a medium to travel. Things requires an electric bell, glass, bell jar, cork, connecting wire, vacuum pump, battery and key. Now the electric bell are placed inside the bell jar. This electric bells are connected to the connecting wire through the key to the battery. Close the bell jar with the airtight cork. When the switch is pressed, the hammer of the electric bell strikes. The gong sound is produced. Now remove the air inside the jar with the help of the vacuum pump. Again press the key and notice the changes. Now allow the air to enter the jar gradually and observe the changes. As the air is taken out, the loudness of the sound decreases and becomes too faint. Finally, you do not hear the sound, even though the hammer of the bell is seen striking the gong as before. You find that the sound slowly starts increasing when you allow the air to enter the jar gradually. We conclude sound cannot travel through vacuum. Sound requires a medium to travel.